Now we want to derive the mirror equation. Now before we can derive the mirror equation, I want to make some preliminary remarks. So the first one is that say you have a mirror like this, and if the light falls onto the normal of the mirror, so normal is perpendicular, and the light falls on the mirror like this at a normal, then it will get reflected back along the normal only. So if light falls on like this arrow, then it will come back along the normal only. And an important point to note is that in the concave mirror, if the light passes through point C, so say this is the ray of light, it is emanating from point B, and the light is going in this direction, it's going in this direction, it touches the mirror here. Note it passes through point C. C is the center of curvature, so it passes through C. Then the light will get reflected along itself, because if you draw a plane here, you can see this light is falling just like it is falling on a normal. So this line is making an angle of 90 degrees here, so the light reflects back. So therefore we have an arrow like this. So light goes like this through the center of curvature and back. Now this depends upon the geometric fact that this distance is the radius, so the radius is perpendicular to the tangent line here. Now also you can again draw a tangent line at P. Now here the light falls at an angle of theta. So again now you should think of light falling at an angle of theta. Then as we have seen before, it will get reflected also at an angle theta, and that is what is happening at point P. So the light is falling at an angle theta, it gets reflected at an angle theta. Notice that now we are talking about a concave mirror, and there are two beams of light coming from point B. So one beam is this and the second beam is this. Notice that these beams are not parallel. Now in case they were parallel, they would have passed through the focus, but now we are not concentrating on parallel beams, we are just talking about any arbitrary beams. Now why are we doing this? We want to find the image of the object. So to find the image of the object, we have to construct rays. So the starting point is you have placed an object AB. So this is the object of height h which has been placed here. So this arrow is the object. So this object, we want to find the image of this object. So you have to draw at least two rays, and the easiest way to draw them is first is to draw through the center of curvature. So you draw through C. So if you draw the ray through C, you know it will get reflected back. So you get this one ray going here and then going back. The second ray goes from B to the pole and then gets reflected at the same angle theta. So this is the point of intersection of two reflected rays. So we are talking about point of intersection of two reflected rays. Now the ray passing through C gets reflected along the same path. So this is one reflected ray. So we have incident ray is also going through C, and the reflected ray is also going through C. So this is the incident and the blue is reflected. Similarly, incident ray 1, so I've written 1 here, it goes to P and then it gets reflected. So this is the reflected ray. So you take two reflected rays, find their point of intersection, and that will give you the image. So image of this object AB is A prime B prime, and we have just shown how to compute the point where the image lies. Now we will use this figure to find out the mirror equation. So it is important to understand how this figure is formed. We now derive the mirror equation. So for the mirror equation, first we have two similar triangles. So triangle this A, P and B, this is similar to triangle A prime, P and P prime. So why is this so? So this angle is 90 here, the angle here is also 90. So angle is theta here and the angle is theta here. So two angles are the same. So thus all three angles are the same. So these two triangles are similar. So therefore H, so you take the denominator as H and H prime, so H prime over H we put minus H prime because by our convention, our sign convention, anything which is measured under this principal axis, so this is principal axis, so anything measured under this principal axis, so this is the principal axis, and anything measured under this principal axis like this object A prime B prime is negative. So you have negative sign. So you take the ratio of heights minus H prime over H, which is A prime B prime, that is A prime B prime over AB. So this ratio is equal to the ratio of the base. So the base here is A prime P, and so this is the base in the triangle A prime P B prime, and this AP is the base in the triangle APB. So this AP is the base here and A prime P is the base here. So that is what you take. So what is A prime P? A prime P we denote by V. Now V is the distance of the image, and AP we denote by U. So you have V over U. So this is the first equation we get, minus H prime over H is equal to V over U. Now focus on this triangle A, B and C. Now in the triangle ABC you have this angle alpha. So tan alpha is equal to H over this distance AC. Now what is AC? AC is nothing but U minus R. So this U minus R is nothing but AC. Now in this small triangle A prime B prime C, so now we are talking about triangle A prime B prime C. Again tan alpha is equal to H prime over A prime C. So again H prime you have to take as negative by our convention, and so minus H prime over this is A prime C. So A prime C is what distance? You know from C to P is R. So C to P is radius of curvature, and we just said we will take A prime P as V. So from C to A prime you have R minus V. So this is the distance we are talking about. So this is R minus V, and in the previous case we were talking about distance AC, which was this distance, and this distance is nothing but U minus R. So this was R, U minus R. So now you equate the above two equations. So you take this equation and rearrange it. You take H here and R minus V here in the numerator, and that's what you get, minus H prime over H is equal to R minus V over U minus R. Now you equate this equation with this equation. So you get R minus V over U minus R is equal to V over U. So this implies, so you take V in the denominator here and you take this in the numerator here. So you exchange these two positions. So you get U minus R over U, this is equal to R minus V over V. So that's what we have done. R minus V over V is equal to U minus R over U. So this thing becomes, so this equation now becomes R by V minus 1, and this equation becomes 1 minus R by U. So you take this minus R by U to this side. So you get R by V, which comes from here, minus 1 you take onto this side, is minus 1 plus 1 you get 2, and minus R by U you have taken on this side, you get plus R by U. Now you divide both sides by R, this gives you the mirror equation, 1 by V plus 1 by U is equal to 2 by R. Now ideally you would like to modify this equation because we are measuring the distance from point P. Since we are measuring the distance from point P, this V is measured from from P to A prime, so V should be negative. So you should put minus V here. Similarly, U, this is measured from P to point A, so this should also be negative. This is equal to 2 over R again is measured from point P to C. Again, the light is incident in this direction and we are going in the opposite direction. So we are going from P to C because the distances are measured from the pole of the mirror. So this is in the opposite direction. From P to C we are going in the opposite direction. So again we have minus R. So the minus sign just cancels out. So you again get the same equation. So this is the mirror equation. Now if the object is placed at infinity, so that is if the object is really far away, so then you just put U as infinity. So if you put U as infinity, you know that 1 by U will be 0. So you put 1 by U 0 here, and if the object is infinity, all the rays will pass through the focus, giving F is equal to V. So instead of V you write F. So let us see this actually. So basically what we are saying is you have a concave mirror. Now we have already seen that if you have a concave mirror like this and say this is the focus of the mirror, if the rays are going parallelly, they will get reflected and pass through the focus. So the image is formed at the focus, and if this is the pole, this distance is V. The image is formed at a distance V from the pole. So that is why instead of FP we know this distance FP is the focal length F, and this F is what we are putting as equal to V here. So otherwise you can see directly from the formula, 1 by U you put as 0, instead of V you plug in F, you get 1 by F is equal to 2 by R, or F is equal to R by 2. So generally this equation is also written as this is equal to 1 by F, where F is the focal length. So F is the focal length. So focal length means that the length from focus to the pole of the mirror. So this length is the focal length. Now we define magnification. So magnification is defined as h prime over h. So h prime is the height of the final image divided by h. So this becomes equal to minus V by U. So you basically just have copied this formula down. So we taken the minus sign from here and put it right here. So that is how you get magnification is equal to h prime over h. This is equal to minus V over U.